Today we're looking at an American Standard train unit. This is a condensing unit you might find out on the side of your house on the ground. And it doesn't matter whether it's a train unit, Goodman unit, Carrier unit. They're all pretty much the same, have the same components for the most part. Now there's a couple repairs that we're going to discuss here that are real common. I would say about 60% of the calls I go on are one of these two items. And while a professional would charge you hundreds of dollars, perhaps over $1,000 to replace one of these components, the good news is that it's something you as the homeowner, if you have a little bit of mechanical skill, it's something you could do yourself. And it might seem kind of intimidating, but there's really not a whole lot to it. One of the things I want to talk about is this run capacitor here, and we're going to look at those a little more closely. And it just has 3 wires going to it, maybe 4 wires, and there's really not a whole lot to replacing one. You just unscrew one, the bracket that holds it in, and you just replace the wires on the new capacitor, and they're marked common, hermetic, and fan. So you would just take the wires that are on the common on your old capacitor and put them on your new one, and that's pretty much all there is to it. If you can paint by number, you can replace that capacitor. The other thing is your outdoor fan motor here, and it doesn't matter, you might have a package unit. So if you were to go up on the roof and look at your package unit, somewhere most likely on top of the unit you would have a fan like this, and it has a bird guard or a grate grill thing. That's to keep birds from flying into it, and it's pretty much the same operation whether you have a package unit on the roof or you have a condensing unit that sits on the ground like this one. Now over here, hopefully your wiring isn't quite as menacing as this, but this, I just set this up out here in my backyard just so I can film this demonstration. And the first thing I would do is pull out your fuse block, pull the disconnect switch out, and I like to set it on top of the disconnect switch. That way I can look with a glance and I can know that it's turned off. And then if your unit's been running, if you've been running it recently, go ahead and wait, I would say 2 hours. And what that does is it gives everything in the air conditioner a chance to cool off. Because if your compressor gets overheated and shuts off, it could take as long as that to cool off, because it's a big metal pot thing and it takes a while for all that heat to dissipate. So you want to wait about 2 hours before you conduct your investigation, like I'm going to explain to you how to do here. So let's say we waited 2 hours. What I would do is turn the thermostat on, and that'll close our little contactor, which is over here, and the unit's going to be ready to turn on. Of course it's not going to turn on because we have our fuse pull out removed. So I like to do it this way. That way I can be outside with the unit and see what's going to happen the moment I put the fuse block in. So when you put the fuse block in, what's supposed to happen is the compressor inside the unit there and the outdoor fan motor should immediately start and work. And if one of them doesn't, then there's a little kind of a diagnostic flow chart type thing. We'll go through that real quick. If you put the fuse block in and this outdoor fan motor doesn't start turning, and the compressor does work and you hear it grumbling along and humming in there, and it's running, and what you'll hear is the compressor will chug along, and the sound will get louder and louder because it's under more and more stress because this outdoor fan motor isn't working. So just go ahead and pull your fuse deal back out there, and in that case the culprit would be your outdoor fan motor. So the remedy, of course, is just to replace the outdoor fan motor. If you were to put the fuse block in and neither the compressor nor the outdoor fan motor would start, then your most likely culprit is this capacitor right here. Now there's one other scenario. If you put the fuse block in and the fan motor starts but the compressor doesn't, then once again your culprit is your capacitor. So just with those little simple 3-step diagnostic remedy there, you can narrow it down to what it is, and like I said, about 60% of the calls I go on are either this capacitor or the outdoor fan motor. So there's a pretty high probability that one of the two are what's ailing your air conditioner, and we'll go through how to replace those. There's really not a whole lot to it. Now, if you've gone through the thing like I said and plugged in your fuses, and the compressor and the outdoor fan motor didn't make any humming sound, didn't do nothing, they didn't even attempt to start, then the next thing to look at would be the power, making sure they have power going to them. What I've done is I removed some of the wires so we could see this contactor a little better, and right now it's in the off position. The little center contacts are kind of popping out. They're on springs, and then when it's turned on, the thing gets sucked in there and the contacts close. So that's on, that's off, that's on. And what we do in this case is we would test to make sure we have voltage, first going to the contactor and then going through the contactor. So this is just a cheap little meter I bought for $2.99, and that's all it takes to check this. And first we have power. It comes in through this right side, so I'll just put my probes across this right side here. Okay, it'd help if I put my fuse block in. You might hear the compressor humming trying to start, but without the capacitor it's not going to be able to. So let's see what's going on here. Let me put these probes on here, and we have 246 volts. Now we want to make sure that power is getting from not only the side where the power is coming in, but the side that actually feeds our components, which is on this side. So we'll test on this side also, and we have 246 volts. So we're able to determine the power is in fact going to our outdoor fan motor and our compressor. You could also trace back the wires to your outdoor fan motor if they happen to go to a circuit block or a circuit board or a terminal block. And we'll talk a little bit more about that later. But what would happen, let's talk about what we would do if we had put our test leads here and we got a 0 and we didn't have any voltage. The next thing we do is look at our disconnect box. We'll look at that next.